Hello, dear learners. You're welcome to today's class. In today's class, we are looking at the concept of coordinate geometry of a straight line. Coordinate geometry of a straight line. So by the end of today's class, you'll be able to determine the coordinates of a point on XY plane. You will also understand what is called a straight line. And as well, you'll be able to determine the gradient of a straight line. So I welcome you to today's class. Let's explore together. The concept of coordinate geometry. Coordinate geometry basically deals with the study of geometrical figures using coordinate plane. Coordinate plane. When we are referring to plane here, we are referring to the X and Y axis, which we are familiar with before now, where you have this on your graph. The vertical axis is the one you call the y-axis, while the horizontal axis is the one you call the x-axis. So every point on the Cartesian coordinate, that is the x and y plane, every point on the Cartesian coordinate can be denoted with its two coordinates, which is the x coordinate and the y coordinate. That is, if you have a point A on a plane, take this as point A on a plane, this place as point A. It has its relationship to this side, which is the x coordinate, and also has its relationship to this side, which is the y coordinate. So every point in space always have its x coordinate, which is the x-axis, and the y coordinate. So this is the way a point is represented on a plane coordinates. That is how high it is, how far it is from the y-axis, and how high it is on the x-axis. So every point always comes with the x-axis and the y-axis on the Cartesian coordinates. Cartesian coordinate basically deals with your perpendicular lines of the y and the x-axis. The y and the x-axis. So that is it. Take for example what we have here. This is 2 points on this line. This is a straight line. By a straight line, we mean a line in which the gradient of any 2 points on the line is equal. So take a look at this line now. This point A and B. If I determine the gradient of point A and B, it must also be equal to, if I pick another point here, let's say point C. So the gradient of this B to C must be equal to A to B, must also be equal to A to C. If it is so, that means that's a straight line. So for this point A, let's try to find the coordinate of this point A on an XY plane. For this one, the A here, you trace it, this point down to the x coordinate. So that is 1. And you also trace it to the y coordinate, yes, this, and that is 1. So the coordinate of point A here is 1, 1. That is the x coordinate, the y coordinate. Alright, how about the coordinates of B? To do that, you also trace it down to the x-axis first. Oh, that is 6. And you trace it to the vertical axis, which is the y coordinate. What does it have at the vertical axis? You see that it's 4. So it can be said that the coordinate of B is 6, 4. 6, 4. Now that is how we determine the coordinates of a point on an XY plane. If I pick a point here, call this point C, what will be the coordinate? To do that, you trace it down to the x-axis and you trace it down to the y-axis to get you the coordinate of point 6. And that is 4, 2. Interesting. So that's great. Let's move forward. Now, we need to understand the concept of gradients. Gradient. Gradient of a straight line is the measure of steepness of that line. Is the measure of steepness of that line, which often we refer it to as the increase in the y-axis to increase in x-axis. So let's look at this. Here, gradient, which we always denote with letter M. You've learned that in your SS1 basic properties of line. So here, if we look at this straight line that passes through the points A and B, if we are to determine the gradient, what we need to do is pick these two lines. We look at this point and also this. So this, the vertical axis from here to here is the change in y, and from here to here is the change in x. The change in x. So the gradient refers to as the increase, the ratio of increase in y to the ratio of increase in x. Recall that the change in y that we have here is finding the difference between the y2 minus y1. By y2 we mean this point of y. This is the y2 and this is the point of y1. This is the point of x1 and this down here is the point of x2. So change in x is equals to x2 minus x1. Hence, gradient of a straight line mathematically is expressed as y2 minus y1 divided by x2 minus x1. Simply put, gradient of a straight line is the ratio of increase in y to increase in x. So understanding that concept, let's take a look at some examples here. The question reads, find the gradient of the line passing through the following. Gradient of line passing through the following pairs of points. So we have 2 points on a line, which is point P and point Q. We are to determine the gradient. So to do this, we go by saying solution. So for the first one, where we have the gradient of line PQ is equals to M, we denote it by M. So from here, recall that we say M is equals to y2 minus y1 over x2 minus x1. So it's easy to do this by saying, if you take this Q part as where you have a y2 and this is where you have x2. Remember, each point is always of the coordinate x comma y. So this is going to be your y1 and this is x1. So to do that, our y2 is 5 minus y1, which is 1. So divide that by our x2, which is 3 minus then our x1, which is 2. So upon doing that, we can say that the gradient m is equals to, find the difference here, which is 4 divided by 1. So m is equals to 4. Hence, the gradient of the line PQ is 4. The gradient of the line PQ is 4. The question 2, remember that A is minus 4 and 3, and we have B to be 5 and minus 3. So gradient of gradient of AB, which is m, can be expressed as m is equals to y2 minus y1 over x2 minus x1, which you can express that as our y2, that's minus 3, minus, then our y1 is 3, divided by our x2, which is 5, minus our x1, which is negative 4. So we put that negative 4. Then mathematically we can say the gradient m is equals to negative 3. You are adding it to negative 3. It will give you negative 6. That's negative 6 divided by this. You are going to have 5 plus 4, because when you multiply negative and negative, it gives you positive. Hence, the gradient of this will give you negative 6 over 9. And if you simplify it further, you have minus 3 can go in 6 and can as well go in 9. That is 2 over 3. Hence, the gradient of the line AB is negative 2 over 3. Negative 2 over 3. So one important thing we must recall from our knowledge of gradient is, on the Cartesian coordinates, whenever your line slopes downward this way, the gradient of this line is going to be negative. It's going to give you negative value. If your line slopes upward this way, the gradient of this kind of line is going to be positive. Your gradient is going to be positive. And if your line slopes horizontally, that is so straight like this, at this point, the gradient here is 0. The gradient here is always 0, because there is no increase in y, but there is increase in x. And if your straight line slopes this way vertically, if it is as straight as this vertically, then the gradient here is undefined. The gradient is undefined. So as a JAM student or YX student, all these are the properties of the lines that you must know. The gradient is undefined at this level because it has changing y-axis, that is, it's changed from this to this, but it's not changing on x-axis. So the x-axis, the change in x-axis is 0, and whenever you divide a value by 0, say 5 divided by 0, what do you think this will give you? It's undefined. Don't make mistake of saying it's 0. It is undefined. So that is the concept under this. Now I believe you understand this. I'll give you time to go through this on your own. This exercise. Find the gradient of the line passing through the points this and this. I want you to take your time. Yes, try it out. You can drop your answer in the comment section provided below. Drop your answer in the comment section provided below. Alright, in response to this exercise, let's go through it together. You can just give it any letter. Say we have let's do the solution. If A is 2, comma minus 3. So our x is 2, our y is minus 3. And if b is also seen as 4, comma 1. So here, the gradients of the line AB, maybe I can just write it subscript. Gradient of the line AB, that's what I'm referring to here, is y2 minus y1 divided by x2 minus x1. So which that one is what we have as our, let's take this as our y2 and our x2, while this is our y1 and x1. So putting in this value, our y2 is said to be 1, that's 1 minus our y1, which is minus 3, all divided by our x2, which is 4, minus our x1, which is 2. So in doing that now, we then look at this 1 minus multiplied by the minus, that's plus, that's 1 plus 3 divided by, you find the difference of 4 and 2, that will be 2. Therefore, the gradient of the line AB can be said to be 4 over 2, which is then 2. The gradient of the line AB given here, these 2 points, or let's say the gradient of the line passing through these 2 points is 2. Now, if I ask you, what can you then say about the property of that line, or what can you say about the flow of the line? Will it slope downward, or slope upward, or vertically, or horizontally? So I will need you to drop your answer to that question. That is, what will be the direction of this line if it is constructed on an XY graph? Will it slope downward, slopes upward, or vertically, or horizontally? So I need you to drop your answer to that question in the comment section. And I want to believe that the objective of today's class has been met. If so, I implore you to join us for the continuation of this lesson come next class, where we'll be looking at the equation of a straight line. Till I come your way next time, I am your mathematics tutor, Ademola Folari. Thank you for your time.